block present time, when they start the communications, and that is the previous block, and we have timestamp version, what message has modified or not, that we using that version of the messages, and we use nonce and target where we want to send the messages and what message is broadcasting. So these are the structure of our blocks we using in our network for the our regular communication network. So these are the proposed mechanism complete for the using complete communications during that. This is a communication module. We use send and receive the packets, input and output keys. We have blockchain logic. There is a mining, inform, others, IBTP and transactions things, and there is also control connected with the vehicle control logics things. These are the showing that present time scenario, like is going on. This based on these signals, sometimes it happen the accidents and this type of things. So what we are planning to, what type of system we are gonna be propose is like this system. In this system, we can see that is all gonna have a blockchain server, and this blockchain server is communicating, circulating our message in the same time. Whenever any vehicle is sending message, is circulated with the all blockchain, they can update their lasers. So as we know that these are the not possible in a, because vehicle has a vehicular communication during some places has a huge amount of the transactions, huge amount of the vehicles communicating. So for that we propose two mechanism of the blockchain. First one is a showing in the local blockchains. These are some local blockchain, and they transmit the main blockchain. So what happened is in here they are overriding the systems. Whenever it store the whole communications in this network, but only important means something has wrong and something vehicle communication has important messages or something, they just transmit to the main blockchain. Main blockchain has a big server, they can store whole informations, and this one is updated in circulated less than within a 6 month we can modify that type of things, update for overriding that information. So these are our simulation work. We did our simulation in our lab. So we using the PyPC and just try to implementing this system in blockchain technologies. So these are the simulation. For here we can see these 4 vehicles coming on the same time, and they have IBTP. Each vehicle has an IBTP, and here we cannot find out that is the hash ID. Each vehicle will provide the hash ID, and what is going on here? Like in here, all corner 4 side is vehicle is coming, and for example, this all side is coming. Before coming on this region, the vehicle is broadcasting the message, I am coming and I am going this way, or this way, or this way, or any way. They broadcasting the message, and all vehicles are doing same thing. So once vehicle reaching on here, they can see their database which vehicle broadcast which message first, and they allow, and now all between these vehicles they can be find out which vehicle has come first, and they broadcast the message. For example, this vehicle broadcast the message, this vehicle is come first. So before moving here, this vehicle they give some reward. In reward, they based on their they provide some IBTP. They just share their IBTP with that vehicles. So in that case, vehicle can be get their IBTP. So what's the benefit of that IBTP is providing to how reliable the vehicle is running on the network or running on the street. So they're providing that type of things. So that is the one benefit is this. Whenever we go to resell our car, so whenever we sell our cars, we just provide our database. You can see I have this much IBTP, so I am the most reliable vehicle. Who has the less, who did the mistakes, they can be reduced their IBTP. You cannot provide take the reward that IBTP. So who has the most highest IUTP, that is most reliable, they can sell their car according to that. And the another way is the IUTP we can use for the insurance. For the blockchain technology, we have stored all informations, we have ledger. So presently what happens, whenever we buy the car, whenever we buy the insurance for our car, we pay for the whole year. Even we are not driving the whole year in our car. We must to drive only 6 months. For example, we just drive 6 months, but we must to pay whole year. So what happens is we can show the insurance company, I am driving this much car and I can pay only for the 6 months, not gonna pay for the another 6 months. So this detail can be benefit for that blockchain technology can be used for this type of features and applications in the future. So that is our implementation specifications. We using the intelligent vehicle intersection use case scenario. The simulation run on local wireless area networks, low latency. So for this is the difficulties. For as I mentioned about the nonce, we reduce our nonce 5. It takes the 62 seconds for the making that type of things, making the communications establishment data. So we try to reduce 1 to 5, and we get it if we provide a one nonce to change every time, we get the list of the 0.0045 microseconds, and we did this 100 trials in our systems, that type of things. And these are some result of our mining rate versus time. That mining rate is the IPS blockchain requires around 400 seconds for the stabilizations. We did that things. And the state change, we using for the state change verification. That means we change about our stop to moving for that things. So we use this state change verification rate versus time for the various network loads. Even that. So state change is the state change verification rate increases in the proportions with the increase in network loads. The how much network get the load whenever package do the communication in the blockchain technology. And this is our demonstration we did in the 2017 last year. Is a 2017, sorry, it's 27. So is last year 31st October we did this demonstration in our university, inside our university. So that is the complete autonomous vehicle, and that is do the valet parking also. So I'm just showing this. This we show for the SK Telecom in the Korean industry, that telecom company, and some government for who is interested in this ministry, transportation ministry. They are seeing, as I mentioned also, like government of Korea, they are providing big huge space for doing the test driving of this autonomous vehicle. But before that we get some license and some formalities. After that we can get that. So this one we just show inside our university for the demonstrations. So from here, vehicle here to move from this way to reach there and self park through the valet parking process. Where is the vehicle start? There we put the camera and computers, so all observer they can watch vehicles movement and everything about how it's going on. And for this we try to implement about the blockchain one, but we have only one car, so we cannot do that. So that our process, we just try to secure that type of things. At these locations we put this one. As for the vehicle can be observed that the location of the parking place. So it has this camera. Through the surrounded camera, we using this mechanism to park surrounded camera with the deep learning algorithms of this. We had uses the radar, and all sensors in this our vehicles. So it's parked now. So this has happened also in some articles. This demonstration will be published in our next day newspapers. They providing this all in Korean. So, and that is the conclusions, like advanced autonomous vehicle security to understand the problems and need for domain of the autonomous vehicle. That is the big issues for the present time. Like someone believe that autonomous vehicle is it cannot possible, but I am like positive man, so I'm always think that it's possible, but also we need to find out the what type of problem and what type of solution we can provide that things. And another, we propose the blockchain technology for autonomous vehicle, this AutoBT. We build the trust, distributed, decentralized, and maintain privacy, reliability. And we have also research scopes, lot of research scopes in this area. Automotive cybersecurity, as we know, as much as the vehicle gonna be use sensors and electronics parts, as much as dangerous for the hacking, can be easily to hack. So that is the new, and we can believe that is the future research area gonna be very huge for this autonomous vehicle in automotive technology. Cybersecurity for the automotive technology. We have that manufacturing, communications, and automotive cybersecurity (EPC). We finding the provider security between the ECU, CAN, control area network, and inside of the vehicle, outside of the vehicle, everywhere. And these are our workshop gonna be based in blockchain-based trust environment. It's gonna be accepted. Is already accepted, and if someone interested, so please submit their paper. That is October 8th is the deadline, January 29 and 23rd. And our organizing committee, Professor Rigi, is going to be publish this workshop. This workshop is also based on the IC, Intelligent Communication, Intelligent Vehicular Communications, and any communications that can be in advance going to be there. Okay, obrigado, thank you, kamsahamnida.
Thank you, Dr. Singh, for this interesting and relevant talk. So now we have some time for a couple of questions.
You can go there.
I'd like to know, in your opinion, what are the main challenges and open problems to implement your solution in a real smart city? What are the main challenges and eventual problems in order to implement your solution in a smart city, in a real city?
In real city?
Yeah, in a big one.
Yeah, basic real city. Yeah, in real city implementations, like first of biggest challenge is the infrastructure. We must to develop that infrastructures, and government not gonna be allowed that type of things, but privately we can do that. Privately we can do that type of things. We can provide servers, and we can organize some specific vehicles whenever there. And second one is like autonomous vehicle is not in real time. So, but whatever vehicle we have, they have a communications environment. They can communicate. They already communicating for the finding the services and finding the locations. That type of things already happening. So the biggest challenge, in my opinion, is finding the infrastructures for the blockchain development and providing the server. So that type of things, is, I believe that. Thank you. Yeah.
Could you please explain again the proof of driving? How it works, the proof of driving, and how long it took to finish a block? How long it takes to finish blocks in your blockchain?
Finish the blocks. As I mentioned that we are just using this only 4 systems, so we cannot whenever communication is going communication gonna be huge amount of that. But in here, we are trying to find the feasibility of the blockchain. Blockchain can be feasible or not, because the concept is completely different. We cannot store, we cannot do the running the vehicle when vehicle is running during that time. We cannot do this type of data storage, that type of thing. So we must to find out the feasibility. We are not concentrating about that how much is block, the size of the blocks, that type of things. As I mentioned, the overriding the blocks. So we think within a 6 months, we're not counting the blocks, we're counting the within a 6 months how much is gonna be communicating will be stored in the blockchain. After that, it's going to be important messages can be forwarded for the main blockchain, and rest of them then override that things. So I believe that type of thing. For the concept of the size of the blocks, we not considering about that in our lives. Thank you.
I'm afraid we don't have more time for questions, so thanks again, Dr. Sin.
Thank you.
And we're moving on for the next talk. Thanks.
Thank you.
Agradecemos ao professor Dr. Madison Sim e ao professor Dr. Jefferson Campos Nobre e convidamos eles a ocuparem os lugares junto à plateia. Teremos agora a palestra intitulada